So let's move on to equilateral triangle. We'll start off by defining what an equilateral triangle is in case you forgot. But remember that an equilateral triangle has to have all congruent sides. Okay, so for example, they always look like this. All three of these sides are equal, so we put those little marks to signify they're congruent. Our first rule is called the equilateral triangle theorem. And this one is saying if a triangle is equilateral, that means if all sides are equal, then the triangle is also going to be equiangular. Okay. So now this is the same one as the last one we talked about isosceles. Like we said, if two sides are equal, two angles are equal. Well, in this case, it's kind of the same concept. If three sides are equal, then we're going to have all three of these angles also be equal. And the converse of that will be the backwards. If a triangle is equiangular, then the triangle is going to be equilateral. So vice versa, saying that if we have three angles that are equal, then we're going to have three sides that are equal as well. The two parts here. It says the following triangles are equilateral. Find the value of x. Okay, so remember, if this is equilateral, all sides are equal. Now, if all sides are equal, then I can say that like 5x is equal to this top side, or 5x equals to that part. I see a lot of people try and do this here. They say, okay, well, if I know all three are equal, then I put 5x equals to the top one, 6x minus 5, and that's equal to 2x plus 15, which is true. They're all equal, okay? But you cannot solve an equation that has two equal signs like that. And so just pick two of them, okay? You can either like pick 5x equals to 6x minus 5 and solve for x, or you can say 5x equals to 2x plus 15 and solve for x. Or you can even say that 6x minus 5 is equal to 2x plus 15. Just pick one, okay? If you solve for x, you should get the same x value for every one of these. Okay, so for example, I want to solve the middle one. The middle one looks about probably the easiest. But if I were to bring this 2x over here to the left side by subtracting 2x, I can get rid of that one, and 5x minus 2x is 3x, equals to 15. Then I divide by 3, and if I divide by 3, you will get that x equals to 5. Okay? And so there it is, the value of x is 5. Okay? Now if they were to ask you, hey, find the measure of the side, then make sure that you plug in 5 here, but 5 times 5 will be 25. So this would be 25 units, and if I plug in 5 here, in the top part, and also for this one, I should get 25 for all these. Remember, all sides should be equal. And if you don't get 25 for all of them, that means that you did the algebra wrong. And you have to go back and redo it, okay? But if I multiply, for example, here, 6 times 5. 6 times 5 is 30, and 30 minus 5 is 25. And I'll multiply 2 times 5 is 10, and 10 plus 15 is 25. So that's how you know you did it correctly, because you plugged in 5 into x, and you got 25 for all three sides. For the second part here, once again, we know this is equilateral, and if it's equilateral, then all angles are equal. And if all angles are equal, once again, you don't have to choose all three. Just pick two of them. Okay? For example, I can say something like 5x plus 10 is equal to, let's say, 6x. And then we can solve for x. We can bring the 5x with this like term by subtracting 5x. This will cancel, and I get 10 equals to 6x minus 5x is 1x, and there's my answer, x equals to 10. Okay. Now remember, I know that I did this correctly if I go back and plug it in. For example, if I plug in 10 here, 6 times 10 is 60, and if you plug in the rest of them, it should also give you 60. And then the last rule here is going to be the angles of an equiangular triangle theorem. Okay, and it says each angle in an equiangular triangle measures 60 degrees. Okay. Let's show you a little proof here. Let's say I have an equiangular triangle where all angles are equal. So if all angles are equal, let's call that 1x, and the top one also has to be the same x, and this one also is going to be x. And what do we know about the angles of a triangle? Is that they all add up to 180. So if I combine like terms, x plus x plus x is going to give us 3x. Then if I divide this one by 3, this will cancel, and then divide that by 3, I will get that x equals to 60. Okay? So therefore, all three angles of an equiangular triangle, or also an equilateral triangle, they're always going to be 60. For the second example here, it says find the value of x, y, and z. They're giving you a hint here. The triangle is equiangular. That means that all angles are equal. And you might be tempted once again to put like 4x plus 40 is equal to any one of these here. You might put 2z, or you could even put 5y minus 40. But remember that you cannot solve for x or for z, because you'll get something like, for example, if I divide this by 2 and by 2 and by 2, I get z equals 2, and then 4x minus 2, sorry, 4x divided by 2 is 2x, and then 40 divided by 2 is 20. How am I going to know what z is if I don't know what x is? Alright, so we cannot set these equal to each other. But one thing you should know about all equiangular triangles is that each angle is measured is 60. Okay, so for example, I know that 4x plus 40 has to be 60. I also know that 5y minus 40 has to be 60. And I also know that 2z is equal to 60. And we just got to solve each one to find the value of x, y, and z. So on the left here, if I subtract 40 to bring the 40 with the 60, which are like terms, this will cancel. What am I left with? 4x is equal to, and 60 minus 40 is 20. I can divide both sides by 4, and I get that x equals to 5. On the middle here, I can just divide by 2, just cancel. What am I left with? I'm left with z equals to 30. And on the right side here, I can add 40 to get rid of that negative 40. What am I left with? I'm left with 5y is equal to 60 plus 40 is 100. Then I can divide both sides by 5. This cancels, and I get y equals to 100 divided by 5 is going to be 20. And so those are my three answers. X is 5, z is 30, and y is 20.